Hello everyone. In this video, we are going to see about degree sequences. Before seeing the definition of degree sequence, first let us see what is partition. A partition of a non-negative integer n is a finite set of non-negative integers d1, d2, etc. up to dp whose sum is n. We denote this partition by, within brackets, we have to mention the each number as d1, d2, etc. up to dp. So a partition is nothing but it's a splitting of a non-negative integer as a combination of some non-negative integers. Now degree sequence. Let G be a P, Q graph where P is a number of points and Q is a number of lines. The partition of 2Q as the sum of the degrees of its points is called the partition or the degree sequence of a graph G. Next definition is graphic sequence. A partition P equal to d1, d2, etc. up to dp of n into P parts is said to be graphical partition or a graphic sequence if there exists a graph G whose points have degree di and G is called the realization of P. For example, if for a number 4, if I am having the splitting of numbers as a combination of 2, 1, 1. The sum of these numbers, that is 2 plus 1 plus 1 equal to 4, is a combination of 4. So, can we able to construct a graph with 3 vertices and each vertex is of degree 2, 1 and 1. If we are able to draw a graph in such a way, then the partition of 4 into such a combination is said to be graphical. Here is an example. Here I am having 3 vertices and I am able to draw a graph with a vertex of degree 2 and another 2 vertex of degree 1. Therefore, my partition of 4 into 2, 1, 1 is graphical. Now, let us show the following partition is not graphic. So, the partition given is 7, 6, 5, 4, 3, 2. From the collection of numbers, first we have to clear about number of vertices of our graph. Here, since we are having 6 numbers, the graph which we are going to draw is consisting of 6 vertices. And then the first vertex is of degree 7. But by the graph theory point of view, if we are having the 6 vertices, the maximum degree of any vertex is at most 5 only. Therefore, there is no chance of having any vertex of degree 7. Therefore, we are unable to draw a graph with a 6 point of at least one vertex with degree 7 is wrong, which is a contradiction. Therefore, our partition as 7, 6, 5, 4, 3, 2 is not graphic. The next example is, here we are going to show that the partition P equal to 6, 6, 5, 4, 3, 3, 1 is not graphic. First, we have to count the numbers. 6, 6, 5, 4, 3, 3, 1, totally 7 values. So, you have to construct a graph with 7 vertex. And then, the first 2 values means that all the vertices of at least degree 2. Okay. So, let us see the example. Here I have plotted 6 vertex and I am trying to plot the graph in such a way that all the vertex, that is the first 2 vertex is connected with all other vertices, which means the first 2 vertex will make the other vertices of degree 2. But in our sequence, it has at least one vertex is of degree 1, which is not possible. Since the first 2 vertices is of degree 6, it will make all other remaining vertices of degree at least 2. But the given sequence consisting of the last vertex is of degree 1. Therefore, we are unable to draw such a graph satisfying this partition. Therefore, the given partition is not graphic. Here I am giving you some examples for you to check whether the graph is whether the partition is graphic. The first one is 2, 2, 2, 1 and 1. So, you have to plot a graph with 5 vertex satisfying this condition and write all the partition of 4 as a sum of positive integer and determine which of them are graphical. For example, 4 can be split as 2, 1, 1 and you can also split it as up 1, 1, 1, 1. Like the way you can have so many combinations for 4. Try to find which combination is a partition. And the last one, 7, 6, 5, 4, 3, 2, 1 is not graphical. Thank you.